The ozone layer, from crisis to global cooperation. In the 1980s, the world faced a significant problem, an expanding hole in the ozone layer. This video digs into the origins of this issue, its resolution, and the ongoing challenges we face in addressing climate change. Understanding the ozone layer. The ozone layer plays a crucial role in sustaining life on Earth. While the sun's UV radiation is essential for various processes, excessive exposure can damage the DNA of plants and animals. Fortunately, approximately 98% of this radiation is absorbed by ozone molecules in the stratosphere. Through a continuous process of destruction and reformation, the ozone layer maintains a delicate equilibrium. The discovery of ozone depletion. In the early 1970s, chemists Mario Molina and Sherwood Rowland made a groundbreaking discovery. They found that chlorofluorocarbons, CFCs, widely used chemicals developed in the 1920s, could upset the balance of the ozone layer. CFCs were initially created as non-flammable and non-toxic coolants for refrigerators, offering advantages over existing alternatives. However, Molina and Rowland demonstrated that when CFCs reach the stratosphere, they break down under UV light, releasing chlorine atoms. These chlorine atoms react with ozone, depleting it faster than it can regenerate. A single chlorine atom can destroy thousands of ozone molecules before forming a stable molecule. The battle for truth and action. Faced with the threat to their lucrative industry, CFC producers launched a campaign to discredit the scientists. They even resorted to accusing them of working for the KGB. Initially, estimates suggested that CFCs could reduce ozone concentrations by 7% within 60 years. However, by 1985, it became evident that ozone depletion, particularly over Antarctica, was happening at a much faster rate. Scientists stationed in Antarctica observed a significant drop in overhead ozone levels during spring, aided by the extremely cold temperatures and unique structure of Antarctic clouds. Satellite data and chemical tests confirmed the role of CFCs in this reduction. NASA's visualizations, broadcast worldwide, captured public attention and raised awareness about the gravity of the situation. Unlikely allies and global cooperation. Despite their general opposition to government regulation, U.S. President Ronald Reagan and UK Prime Minister Margaret Thatcher became unexpected allies in the fight against CFCs. Reagan, having undergone treatment for skin cancer, and Thatcher, trained as a chemist, recognized the urgent need for action. Led by the US and the UK, along with Canada, Norway, Sweden, and Finland, international calls for a ban on CFCs gained momentum. In 1987, representatives signed the Montreal Protocol. This landmark agreement mandated the phased elimination of CFCs and established a fund to assist developing nations in acquiring affordable alternatives without ozone-depleting properties. The Montreal Protocol stands as the only treaty in history to achieve universal ratification, with every country on Earth embracing its objectives. In 1995, Mario Molina, Sherwood Rowland, and their Dutch colleague Paul Crutzen received the Nobel Prize in Chemistry for their contributions. Progress and ongoing challenges. As the use of CFCs declined, the ozone hole began to shrink, and it is projected to completely heal by 2070. However, our work is far from finished. While the ban on CFCs proved beneficial for the climate due to their potent greenhouse effects, the alternatives that replaced them, hydrofluorocarbons, HFCs, also contribute to climate change. Though HFCs are generally less potent than CFCs, they still possess a greater heat-trapping capacity than carbon dioxide, exacerbating global warming. Recognizing this, the Kigali Amendment was added to the Montreal Protocol in 2016. This amendment calls for an 85% reduction in global HFC emissions by 2047. If successfully implemented, it could prevent up to 0.5 degrees Celsius of global warming by the end of the century. The Montreal Protocol as a model for global cooperation. Today, as we confront the existential threat of climate change, the Montreal Protocol serves as a model of decisive global cooperation. It demonstrates the power of international collaboration in addressing environmental challenges. However, it also raises a vital question. What will it take for us to come together again? The Montreal Protocol's success in phasing out CFCs and its ongoing efforts to address HFCs offer hope for future endeavors. As we face the urgent need to combat climate change, We must draw inspiration from the lessons learned from the ozone crisis. By prioritizing collective action, scientific research, and sustainable alternatives, we can strive for a healthier planet and a more secure future for generations to come. The story of the ozone layer teaches us the power of human inspiration and collaboration in the face of global challenges. It reminds us that with determination, sound science, and political will, we can overcome seemingly impossible obstacles and pave the way towards a sustainable future.